In the previous class, we have studied about that we can formulate a right triangle related to some heights and distance problems, where we will be given an angle and either the vertical height or the horizontal distance. The vertical height and the horizontal distance, they will be at right angle. If the vertical height is given, then we can find out the horizontal distance. If the horizontal distance is given, then we can find out the vertical height. And this we can find out using the tool tan ratio. So in this class, we will work out some problems of this type, and these are all previous year's board questions starting from 2000 to 2023. There are about 21 questions. Question number 1. From the top of a tower 100 meter high, a man observes the angles of depression of two ships, A and B, on the opposite sides of the tower as 45 degree and 38 degree respectively. If the foot of the tower and the ships are in the same horizontal line, find the distance between the two ships, A and B, to the nearest meter. Use trigonometrical tables for this question. This question have a marks 4. So we will read the questions once again. From the top of a tower 100 meter high. So there is a tower. And its height is 100 meter. And from the top of the tower, somebody is observing two ships. The ships are A and B. There is a ship here and there is a ship. The ships are on the opposite sides of the tower. And the angle of depression is always from the horizontal. Angle of depression of A this is A, the angle of depression of A is 45 degree. And from the same point, somebody is observing the ship B, and it is at an angle of depression, how much? 38 degree. So we have two right angles here. Let this be CD. See, if I extend this line and this line also, we come across a situation like this. There are two lines and there is two parallel lines and a transversal. Here, this is let me extend this line and this line also. And if I extend this line, so these two are parallel lines, and this is a transversal, and this angle you are seeing it as 45 degree. And now I will write this angle also 45 degree. Why? Because if there are two parallel lines and a transversal is there, or a line cutting those parallel lines, these two angles are called alternate angles. Alternate angles. Alternate angles are those angles inside the parallel line and on either side of the transversal. This is called the transversal. Transversal. So we will have two pair of alternate angles. This is one alternate angle, and these are the other pair of alternate angles. What will be this? Total angle will be 45, 180 degree. So 180 minus 45 is 135 degree. This will be 135 degree, and this will again be 135 degree. But we don't need that angle. We only need this angle is important for us. This angle we can write here. So this is 45 degree. In the same way there are two parallel lines and there is a transversal, and you are given this angle as 38 degree, and here comes the this is B and this is the C and this is B. So this angle and this angle are again, they are alternate angles. So it is again how much? 38 degree here. So here we can write it as 38 degree. Now here we have two triangles. One is ACD and the other is DCB. So what we can write? Angle A and angle, say, DCD, say this is E, and let's say here take a point F. Angle A and angle ED, angle A is this, and this angle we can say that we can write as EDF, EDA are alternate angles. Therefore, angle A equal to angle EDA equal to 45 degree. Similarly, angle B equal to angle BDF equal to 38 degree. What we need to find out? We need to find out the distance between the shifts. We need to find out this distance. What is this distance? So this distance we can find out. First, let us find out this distance and this distance also. Then by adding these two distances, we will get the distance between A and B. This is the case just we were discussed in the previous class. See here the vertical height is given in both the cases. With respect to this right triangle, the vertical height is given and an angle is given. The horizontal distance is to be found out. Here again the same situation. Here again the vertical distance is known, only the horizontal distance is unknown, so that we can find out using tan ratio in both the cases. So from triangle ACD, we need to find out AC. Okay, ACD tan 45 degree equal to CD by AC, opposite side of 45 degree by adjacent side of 45 degree. That is, tan 45 is 1. 1 is equal to CD is 100 meter. And AC we need to find out. So by cross multiplication, 1 means 1 by 1. So 1 into AC equal to 1 into 100 meter. So 1 into AC equal to 1 into 100 meter. So we got what is AC from this right triangle, and it is very easy to find out because the height is given and an angle is also given. So we using tan ratio we found out the distance. Here again we will use the same method. For that, we need to consider the triangle DCB. So what we need to find out is tan 38 degree. Tan 38 degree is opposite side of 38 degree divided by adjacent side of 38 degree. That is CD by BC. BC or CD. Say CD. What is tan 38 degree? Tan 38 is 0.7812. This value you can find out from the trigonometrical table. Equal to CD we know, that is 100, and CB we need to find out. So cross multiplication, this means this divided by 1. CB, we can move the quantities diagonally. CB we can bring here, 1 we can bring here, 100 we can bring here. So CB here and bring this 7.7812 to the right side. So it will become 100 divided by 0.7812. And this you will get it as 128.008 meter. Therefore, so here we got, let it be 2. Therefore, the distance between the two sheets equal to, therefore, the distance between the two ships equal to AB equal to AC plus CB. AC plus CB. ACB we got as 100 meter plus CB we got it as 128.008 meter. So adding these two we get 228.008 and it is approximately equal to 228 meter. The second question. The drone camera is used to shoot an object P from two different positions R and S along the same vertical line QRS. The angle of depression of the object P from these two positions is 35 degree and 60 degree respectively, as shown in the diagram. If the distance of the object P from the point Q is 50 meters, then find the distance between R and S correct to the nearest meter. So in this case, the figure is given. In some cases, the figure will be given, and in some cases, the figure will not be given. The figure is given like this. S and R, Q. So this is the point P. The P is observed from S and R using a drone camera, and the angle of depression is given. So whenever there is an angle of depression, we should measure it from a horizontal. So from this point, the angle of depression is given as how much? It is given as 60 degrees. At this point, the angle of depression is given as 35 degrees, but it is not shown in the figure. So how we will write? This angle is 60 degrees again, because if you extend here it like this, if you extend like this, and if you extend like this line like this angle and this angle are, you can see those angles are alternate angles. So this is 60 degrees. And here we have two right triangles. What are they? One is SPQ, triangle SPQ, and the other triangle is triangle PQR. Triangle PQR. These are the two triangles we have. Triangle PQR and triangle PQS or SPQ. Say, let us write it as PQS only. What we need to find out? We need to find out the distance between R and S. This distance we need to find out. And what is given is the distance of the object P from Q. This is given. This is 50 meters. So we wrote 60 degrees. So from this point also, the drone camera is observing the object P, and that angle, that angle is given as 35 degrees. That means at this point we need to find out, we need to draw a horizontal, and from the horizontal and below the horizontal, this will be the angle of depression, and corresponding to this angle, the alternate angle is this. This will be 38 degrees. I am writing this separately here. Say this is PQ. Okay, and this is R, and here we have a parallel line. This angle is given as 35 degrees. So corresponding to this angle, this is the corresponding alternate angle. These two are alternate angles, a pair of alternate angles. If this is 35 degrees, then this will be 35 degrees. So we can write this angle as 35 degrees. This is R and this is, here it is Q. This is 90 degrees. So these two are the same figure I have drawn. So how we will find out RS, the distance between points R and S? Let us first consider the triangle PQR. From triangle PQR, take tan ratio of 35 degree. Tan 35 degree equal to QR divided by PQ. Opposite side of 35 degree divided by adjacent side of 35 degree. That is, what is tan 35? Tan 35 is 0.7002. And QR we do not know, but we know what is PQ. PQ is 50 meter. This implies QR will be equal to, multiply this, 0.7002 into 50 meter. And that is equal to 35.01 meter. So we obtained QR. Now let us consider right triangle PQS. Again take tan ratio. Here see, PQS is that triangle. PQS, and the angle is 60 degree. So tan 60 equal to QS by PQ. Tan 60 degree equal to QS by PQ. So from that, tan 60 we know it is root 3 equal to QS we do not know. QS by PQ is 50 meter. So from this, QS equal to root 3 into 50. QS is equal to root 3 into 50 meter equal to 1.732 into 50 meter. 1.732 into 50 equal to 86.6 meter. So we have PQ equal to how much? 35.01 meter, and we again have now QS also we have how much? 36.6 meter, 86.6 meter, 86.6 meter. So we have this total distance and we have the distance from here to here. So the remaining distance will be the distance between R and S. So RS can be found out from 86.6 meter minus 35.01 meter. So the distance between R and S, that is equal to 86.6 meter minus 35.1 meter. Before that, let us write an equation. QS minus QR equal to 86.6 meter minus 35.01 meter, and that is equal to 51.59 meter. 51.59 meter. And if you make an approximation, the question is, in the question it is asked to give the answer to the nearest meter. So if we convert it to the nearest meter, 51 meter and 59 centimeter. So since after the decimal 5, it is 59, it is more than 50, so we will take it as 1, so 51 will become 52. Answer is equal to nearest to the nearest meter, so it is equal to 52 meter. So here we had two triangles, and both the triangles have the base or the the horizontal distance is the same for both these triangles. And then using the horizontal distance, we found out the vertical height of this triangle. Again, we found out the vertical height of the other triangles. Then we made a subtraction to get the required answer. Question number 3. The angle of elevation from a point P to the top of a tower QR 50 meter high is 60 degree, and that of the tower PT from a point Q is 30 degree. Find the height of the tower PT correct to the nearest meter. So here the angle of elevation from a point P. So there is a point P, and the angle of elevation. So we need to find out, we need to draw a horizontal, and the angle of elevation is 60 degree. The angle of elevation from a point P of the top of a tower QR. So the tower QR is observed. This QR is the tower, and the angle of elevation of the top of the tower. So angle of elevation is angle above the horizontal. That is observed as 60 degree, and the QR is given as 50 meter. This is 50 meter. And that of the tower PT. So P, from there is a tower, the tower is PT. So that tower should be from P. And that of the tower PT. That of the tower PT means angle of elevation of the tower PT from Q. That means from Q. This is the line of sight, and this is the angle of elevation. That is given as how much? 30 degree. So here again we have two right triangles, of which these two right triangles have the same base, or the horizontal distance is the same. One vertical distance is given, the other vertical distance we need to find out. We are asked to find out the height of the tower PT. This is PT. So this we need to find it out. So how we can find out? So for this we need to find out, we need to consider this triangle. Which triangle? PQT. So 30 degree angle is given, but PQ we do not know, and TP also we don't know. So how we will find out? We will first consider which triangle? this triangle, and this triangle, this is PQR. So here the vertical height is given and angle is also given. So we can readily find out the horizontal distance, and this distance it is the same because PQ is common to both these triangles. So let us first find out PQ using triangle PQR. From triangle PQR, tan 60 degree equal to QR by PQ. Tan 60 is √3. QR is 50. PQ we do not know. So by cross multiplication, PQ will be equal to 50 by √3 meter. So this knowledge we can use in triangle PQT. So from right triangle PQT, tan 30 degree equal to PT by opposite side of 30 degree by adjacent side PQ. Tan 30 is 1 by √3 equal to PT. PQ we know it is 50 divided by √3, that is 1 by √3 equal to PT divided by 50, and this √3 will go to the numerator here. Okay. Cross multiplication will give PT into √3. Multiply this numerator with this denominator into again √3 equal to 1 into 50. Therefore, PT equal to 50 divided by √3 into √3 equal to 50 divided by 3 equal to 50 by 3 is 16.66 meter, and if we write it as to the nearest meter, then it will become 16.6. So we will take it as 1. So it is 17 meter.